Aloha, my Gen Chem 2. We are back. This is our final video in this series for integrated rate law. I love it. We are going to tackle second order in this video. Remember, we've got trust issues in our class. I'm not going to actually tell you in your homework and in your exams what the order is, but I wanted to show you how to go through your process again and show you an example of a second order, what that would look like. That way you've got in your videos 0, first, and second order, all for the integrated rate law. So let's review. Let's go through our process. With our kinetics problems, like I said in our first day together, we are going to have 7 different types of problems in this unit. And the first thing we've got to do is figure out which type of problem. And then we have a process once we know what type of problem. So as we take a look at our problem or our little example that we've got here, we've got a decomposition of NO2. It's a function of time. And we need to calculate the order, the rate constant, and the concentration. Okay, so we know from our other videos, the first thing I like to look at to figure out what kind of problem we're looking at is our data. And our data for integrated rate law is time and concentration. So I'm going to mark on here, we're looking at time and concentration. I love it. So once we know, okay, we're looking at time and concentration, how do we tell between our general rate expression and our integrated rate law? We'll look at our data set. It is quite large. That's one way to know. And another one is that our general rate expression doesn't give us order or our rate constant, or let us solve for a particular concentration at a certain time. So this really is our most information for the money with the integrated rate law. So how are we going to tackle this? Let's go through our process that we've been learning. The first thing we do is you hit pause and we need to enter our data. We have to take this data and plot it. And how do I know that? Because there's only 3 ways to solve for order. Number 1, if you have your rate law, and you can solve your rate law, you can do that. But remember, what kind of data do you need for that? You need rate and concentration, and you don't have that. You have time and concentration. The second is that you can plot and look for your linear plot. That's what we're going to focus on. And then number 3, of course, is sassy wording and using units of K. What would our units be for K? Well, I often keep that a mystery, but you definitely want to read your problem. And if I give the units for K, that gives away order right away. And we've been writing that with our equations. So let's focus on the plot method because that's kind of the longer one. That's the one we want to practice in class on Wednesday. So what do? You're going to get a pretty large data set, and you're going to enter that either on your calculator or in Excel. Now, I happen to prefer Excel because we need to display the equation. We actually need the line equation, and we need that R squared value. And it just depends how comfortable you are with your calculator. Some of our calculators, it's not easy to get to this or to display this. You can get to a graph pretty quickly, but you can't always get to that information. So I prefer Excel because it's pretty easy to get to these. Okay, so this is where you want to hit pause and you want to enter your data. Okay, so now that you've got your general data put into your Excel, what's the next thing we do? Okay, what are we looking for? We need to figure out if we have 0 order, first order, or second order. And why do we care? Each one has their own set of equations. So we can't do anything until we know our order. Our order has to come first. So in our process, we have to solve for order first. How are we going to do that? We're going to plot our time versus concentration, just as is, not manipulated. That's our 0 order. Remember, our first order was the natural log of concentration. And then if those two don't work, we've got 1 divided by, or the reciprocal of our concentration. So we're actually going to always just get in the habit for every integrated rate problem, plot all 3. So we're going to take this data that we have right here, and before we do anything, we're going to manipulate it. So take a look on your Excel, and let's add 2 more data columns. Let's take the natural log of that NO2, and let's take the reciprocal of that concentration of NO2. Now, this is another reason I like to use Excel, because you can use your math functions on Excel. We have an ln function. It's under the math functions tab. Scroll down to ln, and then you can simply highlight the cell that you need the natural log of. So you're gonna put your cursor in this cell, and then you're gonna go to that natural log math function, and then you're gonna highlight this cell. And Excel will do all the rest for you. And then I have a super secret shortcut. If you hold the cursor over that little corner after you've entered that data, you'll get a little plus sign there. Scroll that all the way down, and Excel will fill in that whole column for you and give you the answers. And then we can do the same thing here, only this one's a little bit trickier. You can use quotient, but I tend to hit enter. I'm sorry. That is a really fluffy. I tend to hit equals 1 divided by, and then I'll highlight the cell. And then same thing. I tend to use my little shortcut and just scroll all the way down. And then your data actually happens pretty quickly. Okay, now what's the next step? So once we've converted our data, so we've manipulated all of that data, we've got all 3 options. Now we need to plot all 3 options. And we're going to do those in a scatter plot, just like the last 2 videos. You're going to choose a scatter plot, dots only, so that little window that looks like that. And that is under Insert if you haven't done this before. Choose your scatter plot. And then what I do is I highlight time and concentration, and then enter your scatter plot. And then your Excel will pull up the plot for you, and you'll have just the dots at first. And then if you right-click on one of those data points, you want to go ahead and add a trend line. I know this is repeating. You want to add a trend line. I just got a little sassy there. Add your trend line, and then at the bottom of that little scroll window, you want to display equation, and you want to display our squared value. And then that'll give you all of this, which we need in our problems. So take a look at that first plot. That is time versus concentration. And that is unmanipulated concentration. Okay, how does that line look? Kind of crappy, right? And how do we tell? Are we even close to 1? Not so much. So that's probably not our winner. Okay, then we switch to that next plot. We're looking at time versus the natural log of concentration. And then, okay, now we're getting better. We're getting closer to 1. So between the 2 of them, the natural log is the winner, but that's not really super awesome, r squared. So let's just double check that third plot and see what that looks like. Aha, now we're talking turkey. Look at that. Your r squared value is 1, and that is coming up for our time versus our reciprocal of concentration. This is screaming second order. So this is how we spot which order we have in our reaction. This is genius, because as soon as we display that equation, we get 2 for the price of 1. We've just learned from this linear plot that it is second order. That's going to tell us our series of equations to use. And we also just got our K value. That's the slope. Okay, so our first 2 questions are answered. What is our K? Let's read that number. Love it. Okay, so we now know the rate constant, and we know that this is a second order reaction. Now we can solve the problem. We're asked at 2,000 seconds to predict the concentration of NO2. Well, can I just read that from my data table? No, because our data table ran out at 1,000 seconds. So we really need to actually calculate that. So what second order tells us is which equation to use. I love it. So let's refresh. That was on our first video. Let me give you those second order reactions again. Our second order reactions are 1 over that concentration at any given time is equal to that rate constant times time plus the reciprocal of that initial concentration. Okay, so remember our moles, we go to 1. This is our rate constant. This will be 2,000 seconds. Our rate constant we just solved for. That's our 0.255, okay? This we can read from our data, that's initial. And this is what we're gonna solve for. Okay, perfect, I love it. Let's put in some numbers. And this is what we're aiming for. So let me put in specific, we're looking for NO2. And we're looking for 2,000 seconds. So I'm just going to remind myself. Okay. All right. So if A is 1, so then I'm going to take that 0.255 times 2,000. And then what are the units of our rate constant? Anybody remember the units for a second order reaction? Isn't that maybe 1 over molarity times seconds? Okay, perfect. And then check this out. Watch what's going to cancel, seconds and seconds, and you're left with 1 over molarity. And then what are we putting in over here? Our initial concentration, and that is a reciprocal, isn't it? So our initial concentration is we better go on this first one. It's easier to read. What is that initial concentration? 0.01. Let's put that in. Molarity. Aha, check that out. Your units match 1 over molar, 1 over molar. Okay, so let's do a little bit of math. What do you get? Well, I'm getting for that reciprocal, I get 610. Anybody else get that? Get about 610. But now this isn't the final answer, right? And we know we're going to double check. 610 makes no sense with your data. But remember, you're not quite done. You're still in the reciprocal form. So go ahead and hit that button on your calculator, that x to the minus 1 or 1 over x button. And then let's get the actual concentration. And when I do that, I'm getting 0.00164. And that unit on that would be... now that would be molarity, right? Because we just did the inverse of that, so that is molarity. Now, does this make sense with our data? Let's go see. Okay, we ended at 1,000 seconds with a 0.00282. So we expect to be about half-ish of that, and are we? We are. So that means that data makes sense. That I love it. Okay, so I hope you feel like we're going through a process for this integrated rate law, and we are. So this is what we need to practice on Wednesday, and then we're going to go through and we're going to take this and write it on our cheat sheet and have a nice process for all of these problems. I love it. Okay, so this one was second order. I hope you actually paused and did some of this plotting along with me. Double check these numbers, see that you're getting the same thing. And if you're using your calculator instead of Excel, make sure we're all real darn close and you know how to get those values. All right, we'll see you guys soon.